Hi there, and thanks for tuning in. Today we're going to be looking at lesson 3.2, part 2, linear functions. You will need graph paper for this one, so make sure you have that ready when you're taking your notes, because you're going to be graphing a few things. And today we're going to be writing down 7 things, so let's go ahead and get started. First thing we want to know is what's the difference between discrete and continuous domains. A discrete domain is a set of input values, usually whole numbers or intervals, and only consist of certain numbers. And you can see them like this on the graph when they're just plain dots. But a continuous domain is a set of input numbers that consist of all numbers in an interval. So if you see it on a graph like this, it looks like an inequality. Let's go ahead and take the time now to pause the video here so you can write down the differences between discrete and continuous, and then once you're done, click play to see how it's done. So for these, we're just going to look at both of them and determine if its domain is discrete or continuous. The first one, you should remember that this is discrete, okay, because there is no interval. However, with letter B, it is continuous because there is an interval. Okay, that's the basic, shortest way to explain those. Here are a few that you're going to try. So let's go ahead and pause so you can try 2 and 3. And once you're done, click play. So again, number 2 is discrete because there are specific numbers and there is no interval. Whereas number 3 is continuous. And that one would be because there is an interval here. Okay? The next thing we're going to talk about is looking at linear functions and then determining if they're discrete or continuous and then graphing them. So here's where we're going to be using your graph paper. It says the linear function y is equal to 15.95x represents the cost y in dollars of x tickets for a museum. Each customer can buy a maximum of 4 tickets. Find the domain of the function. Is the domain discrete or continuous? And we do want to keep this in mind, that we can buy a maximum of 4 tickets. So for this one, the domain would be discrete because you can only buy whole tickets. So you can't buy like 1.5 tickets or 3.5 tickets or 2.2 tickets, okay? So then what it says is to graph the function using its domain. So normally what I do here is I do an x and a y table, and we have 0, 1, 2, 3, and we could also put 4 here. So, and just really quickly, make sure you're including the domain as well, and letter A. So if we bought $0, it would be 0 money. If we bought one ticket, it would be $15.95. If we bought 2 tickets, it would be $31.90. If we bought 3 tickets, it'd be $47, run out of room here, and 85 cents. If we bought 4 tickets, it'd be $63.80. Okay, so you just use your calculator, plug those in. And then what you're going to do is go ahead and write down your graph. So here are my tickets, 1, 2, 3. These are the independent variables. And then since I go up by almost 10, so I can maybe start by, say, 10, 20, 30, 40. That's going to go off the graph, but that's okay. Okay, so I'm just going to start graphing 0 to 0. 1 and $15.95, 2 and $31.96, 3 and $47.85, and then 4, that'll be a little bit above the graph, okay? And then you notice whenever you connect them, oops, actually, psych, just kidding. You're not going to connect these because it's a discrete domain. And so each one will have their individual point. If this was continuous, then you would connect them, okay? So here's one that you're going to try. The linear function m is equal to 50 minus 9d represents the amount m in dollars of money you have to have after buying D DVDs. You're going to do 2 things here. Find the domain of the function, so what are the potential domains, is the domain discrete or continuous? And maybe only find like 4 domains here, okay? And then you're going to graph the function using its domain. So let's go ahead and pause the video here so you can try it by yourself, and then once you're done, click play to check your work. So for letter A, it says find the domain of the function. Is the domain discrete or continuous? For number 4, your domains could be 0, 1, 2, 3, and 4. And that's going to be discrete because you buy whole DVDs, right? You don't buy a DVD and a half. Otherwise, it won't work. And then it says graph the function using its domain. So when I used my X and Y table, a little bit bigger this time, I just put 0, 1, 2, and 3 on there. So $0, I would still have, or 0 DVDs, I would still have $50. 1 DVD, I would have $41. 2 DVDs, I have $32. And 3 DVDs, I have $23. Okay? So when you graph it, you're just going to use those points. And then I went up by maybe 10s here, so 10, 20, 30, 40, and 50. Okay, so $0, $50 left. Or 0 DVDs, $50. $1, or 1 DVD, 41. 2 DVDs, 32. 3 DVDs, 23. I skipped way over for number 3. Okay? And we are, again, not going to connect the dots because that's discrete. Okay? Here's another one we're going to try and look at. A cereal bar contains 130 calories. The number of calories, C calories consumed, is a function of the number B bars eaten. Does the situation represent a linear function? Explain. And then B, find the domain of the function. Is the domain discrete or continuous? And then C would be graphing the function using its domain. Remember, if it is a linear function, it would have to have a continuous rate of change. Okay, so think about that for letter A. Let's go ahead and pause here so you can try number 5, and once you're done, click play. So for letter A, this does represent a linear function because there's a consistent rate of change. Okay? For this one, the domain could actually be continuous because you could eat half of a bar or a portion. Okay, so like you could eat 1.5, 1.25 bars, etc. So the domain could be anything greater than or equal to 0. Okay, so on your XY chart, I just started with 0 and did 1, 2, 3. 0 bars means 0 calories. 1 bar would be 130 calories. 2 bars would be 260, and 3 bars would be 390. Okay, so over here in my graph, I'm going to have 1, maybe space them out a little bit more, 2, and 3. Okay, and then let's do maybe just by hundreds. Okay, so here we go. 0, 0, no calories. 1 bar, 130. 2 bars, 260. 3 bars, 390. Okay, and then since this is continuous, you will connect the points because you can eat anywhere from 0 all the way up to 3. So 0.5, 1.5, 2.1, 2.9 bars. Okay? The last little bit of these notes is we're just going to talk about, is the domain discrete or continuous, and then explain. So for number 6, you're just going to try this one on your own. It says input the number of stories, would be 1 story, 2 story, or 3 stories, like on a building. And then output would be the height of the building in feet, 12, 24, 36. So let's pause here real quick to determine, is this discrete or continuous? This one is discrete because in order to build a building, you need whole floors. You cannot have half floors, sorry about the bell, So that one would have to be discrete. Okay. The last one for number 7, explain how to determine when a graph has a continuous or discrete domain. So let's go ahead and pause here real quick and just determine the differences. And then once you're done, click play. When you have a continuous domain, your domain can include an interval. But when you have a discrete domain, your domain has to be specific numbers, so it cannot be an interval. Maybe even consider whole numbers here too. That's going to conclude our notes for today. Thanks so much for tuning in, and we'll catch you next time.